Right. Good morning or afternoon, whenever you're watching this. We are in week 8 statistics, lesson 19.1, probability and set theory. So, word of warning this week, we have a lot of vocabulary and I'm kind of sorry for that. But at the same time, most of the work is going to be uh, knowing what the vocabulary says. So, the actual math isn't very hard, but there's going to be a lot of symbols and a lot of new words that you need to learn. And once you learn what they mean and you learn to apply what they're asking, it's really not that bad. So, what I have here in front of you is a set of vocabulary words that you need to know. Right here, I have the word set. It's a collection of distinct objects. The way that you're used to seeing it is numbers that are grouped together by brackets. Do you see the brackets that are right here? Yeah, that goes with the definition for the element. Element is each object inside of a set. The elements that you are going to be dealing with are going to be numbers. So, for example, a set is denoted by having this, and let's say a set of numbers, a set is of numbers less than 5, right? That means all the numbers that are in between that are less than 5 but bigger than 0. So this would be 1, 2, 3, 4, and 5. Right? That is my set of numbers, and there are 5 elements inside of this set. Why? Because there's 5 numbers. Remember, element here, for all intents and purposes, element is going to refer to the amount of things inside of a set. That's 5 of them. That's 1, 2, 3, 4, 5. If there was 6 numbers in there, there'd be 6 elements in there. If there were 7, and so on. But they need to have these brackets, and they need to be referring to a set. So set and element are 2 vocabulary words that go together. Then we have something that's called a universal set. It's a set of all elements under consideration that's represented by the symbol U. You're going to see this a lot later. And pretty much when I say set U, right, that's all the numbers within the parameter that I gave you. So for example, if I told you, I need you to group certain numbers together, I need you to group all the numbers uh, greater than 0 and less than 3, right? Then there's only 1 and 2 because 1 is bigger than 0 and 2 is less than 3. So this would be my universal set. Whatever problem I'm doing is only going to deal with those numbers inside the universal set, right? And then you're going to see something else. You're going to see like stuff like set A and set B. These are what we call conditions. Conditions about this. So set A is going to be a subset, and a subset is numbers that belong in set U, but do not include all of set U. They're just part of set U. They're just broken up into different groups. So set A could be any number less than 2, right? Well, of all the numbers inside set U, the only number that's less than 2 is just 1, right? That would be my set A. And set B could be numbers greater than 1. Well, there's only 1, there's 2. Set A and set B, right? These are what we call subsets because they go into set U. Set U has all the numbers that you're considering for the problem, and set A and set B are just part of set U. They're just very more specific parts of them. Smaller, but they all fit inside of set U. Okay, so sorry about that. So now we're going to move on to natural numbers. All whole positive numbers, including 0, right? Rational numbers, non-repeating decimals and fractions, and irrational numbers, repeating or never-ending numbers such as pi or square root of 2 or infinity. So I have examples here. The reason why I'm putting these is because in your homework and practice, they might ask you about natural numbers, rational numbers, and irrational numbers. They're just referring to these, right? That's all it means, okay? So just be ready to, whenever they ask you for those, they just look at these examples, come back to this, or write them down in your notes. Okay, so in case you can't tell, this is going to be it's going to be a longer than normal lesson. Okay, so let's skip that for now. Right, so what is the deal with sets, notations, and number of elements in the set? So here I made a graph. Make sure to screenshot this, write it down, whatever you want to do. But make sure you have this because this is very important. Everything that we're going to do, all the examples are going to be based off of this, right? Now, this isn't going to be everything that you're going to see. For example, I have on the left-hand side, it says set, right? So there are three different sets, set A, set B, and set C, as well as the universal set on the bottom, right? Now, there are set A, B, and C have different conditions, but they all fall under the universal set. The universal set on the bottom, we're going to start here on the bottom. Let's see what it says. The universal set is all natural numbers less than 10. Now, natural numbers, for those of you who don't know, are just positive whole numbers, right? That means, so you see down here, I have U, right? The set of U is 1, 2, 3, 4, 5, 6, 7, 8, and 9, because I'm only counting numbers that are less than 10, but greater than 0. That makes my universal set. All the numbers I'm going to be dealing with for set A, B, and C have to be inside the U, the set U, which means that these are all the numbers. I'm only going to deal with numbers 1 through 9, right? Okay, now let's find out what the condition for set. In order for you to be in set A, there's going to be, it'll be any number from 1 to 9 that follows this rule. Set A is a set of prime numbers that are less than 10. So in order for you to be considered in set A, you need to be a prime number, and you have to be less than 10. And I can only pick from the numbers inside my universal set. So prime number just means a number that can only be divided by 1 and itself, right? So here I have 2, 3, 5, and 7. For those of you wondering, is the 1 considered a prime number? Short answer is no. No, it's not. Let's move on because we have a lot of other things. But for now, just know 1 is not a prime number in this case. So 2, 3, 5, and 7, right? So here, 2 can only be divided by itself in 1. 3 can only be divided by itself in 1. 5 can only be divided by itself in 1. And 7 can only be divided by itself in 1. All the other numbers in universal set, right? The 4 that we didn't include, the 4, the 6, the 8, and the 9, they can all be divided by other numbers. 4 can be divided by 2, and it could also be divided by 1, right? Since it has multiple numbers it can be divided by, we're not going to include it and say, we only want the prime numbers, right? Okay, so that's the set notation. That's my set. I have the brackets. I have all the numbers inside of set A, and number of elements inside the set. This idea of number of elements, remember I said that elements, we're just going to refer to them as numbers? Well, that's what I'm doing here. I have n, which is the number, and of set A. How many numbers are inside of set A? Well, I counted, right? 1, 2, 3, 4. According to me, there's 4 numbers inside of set A. And that's all that means. That n and the A inside, all it means is the number of numbers inside of set A. Okay, so we're going to move on to set B, right? Set B is a set of even natural numbers less than 10. So even natural numbers less than 10, that means that it's all the even numbers inside of set U, right? So if we look at set U again, what are all the even numbers? Oh, it's 2, 4, 6, and 8. Just like I have here, 2, 4, 6, and 8. And there's also happens to be 4 numbers in here too. So the number in set B is 4. Number of elements in set B, there's 4 numbers in set B. Now, all these symbols you're going to use later, so that's why I'm explaining each symbol individually, right? Last one, set C is the set of natural numbers less than 10 that are multiples of 4. Remember, okay, so this is a little bit more complicated. In this set, the only numbers that are allowed in this group are the numbers in set U that are natural numbers. Well, all the numbers in set U are natural numbers. Natural numbers just means that they are positive whole numbers. So 1 through 9, they're all natural numbers. Okay. They have to be less than 10. Okay. 1 through 9 are all less than 10. That's 2 out of the 3 conditions. They also have to be multiples of 4, right? That means that two numbers multiply. One of them is a 4. 4 times one number is going to equal these numbers. The only numbers that are multiples of 4 are going to be 4, because 4 times 1 is a multiple of 4, right? That's where we got the 4 from. And 8, because 4 times 2 is going to be 8, and 8 is still less than 10, and it's a natural number, which is why it belongs in set C. Notice there's only 2 numbers in here, and that's okay. N, right? The number of elements in the set N is number of numbers inside of set C. N of C is 2. There's 2 numbers inside of set C, and that's what that means. As far as the last one goes, where it says NU is equal to 9, that just means the number of numbers inside of set U. There's 9 numbers, that's why I put a 9 there. Okay, so at this point, this video is quite long. You can pause it, take a break if you need to, come back to it. This is what I'm asking you in the warm-ups, right? I'm gonna ask you something about this. If you feel like you can keep going, keep going. But if you need a break, take a break. Just make sure you get through everything, okay? All right, the next part to this. Keep all this in mind. We're gonna come back to this, right? These are the conditions that we're gonna be using. Let's apply this, right? Okay, so here's another chart, right? And I'm gonna apply the symbols. These are the symbols you need to know, because in the homework and practice, all the problems are gonna be using these symbols, right? Now that you know what set is, this is a little bit more of what the problems are gonna look like, right? They're gonna ask you certain things using symbols. So for example here, the term, right? Set C is a subset of set B if every element of C is also an element B. Okay, so what does that mean, right? They're saying that all the numbers in set C belong inside of set B if all the numbers of C are also in element B, right? The way that we write that whole sentence in English into math sentence is what we have here in the notation. C, which represents set C, and then we have this symbol. It looks like a kind of sideways U, right? Do you guys see that? Where it says that represents the word subset, right? That is the symbol for the word subset. So what I'm reading here is from left to right, set C is a subset of set B. What could that possibly look like? Well, if you look at the Venn diagram, I have a drawing, right? I want you to picture the whole box. The whole box is all the numbers. That's U. If you notice there's like a U here, right? This is the universal set. Now, we're gonna use the universal set from this, right? Our universal set, remember, is 1 through 9. That's what we're gonna do here. So numbers 1 through 9 are all in the box, right? They belong in the box. That's the universal set. However, set B only has certain numbers in it, right? So if you look at set B, we only have 2, 4, 6, and 8, right? 2, 4, 6, and 8 are set B, right? They belong in that set. But within that set C belongs in there because all of set C can fit inside of set B, and all of set B fits inside of set U. So if you look at the example I have there, right? 4 and 8 is set C, right? Set B includes 4, 8, 2, and 6. Now let's see if that's true. Set B was all even numbers, right? So set B has 2, 4, 6, and 8. And set C only has 4 and 8. So yes, set C fits inside of set B, and set B fits inside of the universal set, which is the rest of them, right? All the numbers are represented. They're just grouped in different ways. That's all the notation is saying. Okay, so next one. The intersection of sets A and B is the set of all elements that are in both A and B. Okay, what is this saying? The translation to this is just saying that this word intersection, right? This is where it can get a little confusing, right? The intersection of sets, right? Intersection just means that it's kind of like asking, what do they have in common? What do sets A and set B have in common, right? So if you notice it's A intersection B, what number is inside of both set A and set B? That's what I'm really asking. So if you notice, the U is all the numbers, right? There's a box. Inside that box is sets A and set B. Set A and set B have a numbers in common. So let's break this down. Numbers 1 through 9 all exist inside that box, right? If you look at the example section, 1 through 9 are all inside this box. They're all accounted for. However, set A, if we look at the numbers inside of set A, is 2, 3, 5, and 7. Set B is 2, 4, 6, and 8. So if you notice, the numbers that are only inside of set A and not inside of set B are going to be 3, 5, and 7. That's the numbers that they don't have in common. Set B has only numbers 4, 6, and 8, but the number they both have in common is number 2. That is the intersection. So what number intersects between A and B? 2, right? That's all there is to it. You just have to know to interpret it and figure out what they're asking. Okay, so to recap, intersection just means what do the sets have in common? What numbers do they have that do they share, right? In this case, they share 2 because 2 is inside of set A, it's also inside of set B. Okay, so the next one, union. Union is denoted by a U, right? If you see right here where it says union on the bottom, A union B. What am I looking for? The union of set A and set B is all the elements that are in A and B. Union just means to combine. They're asking you, hey, can you combine sets A and B together? What would that look like? Well, if I combine A and B, I'm not combining the rest of U. I'm just combining what's inside of A and B. That means 2 because they both share. So 2 belongs in both. So we start with 2. There's a 3, there's a 5, there's a 7. There's also a 4, a 6, and an 8. The union of set A and B includes all the numbers except 1 and 9. 1 and 9 is still in the U section. It's still in the universal section. 1 and 9 don't belong in sets A or B, right? But all the other numbers do belong in set. When we combine the sets, we end up with all the numbers within those sets. That's all I'm asking for. Just combine those two, right? Okay, the last one is called a complement. And this one's a little bit, it looks more complicated, it's really not. The complement of set A is a set of all elements in universal set U that are not in set A, right? So here, if you notice, we're only dealing with set A here, right? Which means that I have to figure out what set A is. We know that set A is 2, 3, 5, and 7, right? We know that the universal set is all the numbers 1 through 9. They include 2, 3, 5, and 7, right? So if I just want the complement of A, that means that I'm going to take the universal numbers that are not in set A. So if set A, if you notice here, it's 2, 3, 5, 7. I don't want those. I don't want the numbers inside set A. I want all the other numbers that are in set U that are not set A. That's numbers 1, 4, 6, 8, and 9. Right? I want the rest of the numbers. Okay, so if you're like, I don't understand what you just said, pause the video at this point, take a break, look at your notes, right? Come back to this video and watch the rest of it later. Or if you want to power through it, just watch all of it and then watch it again. Right? I'm just trying to make sure to give you points in which you guys can take breaks at. Okay, now that we know what all this is, let's move on to what some of the problems might look like. Okay, so I gave you that whole thing, and what is that whole thing for? It's to find the probability of an event happening. So if you notice, probability measures how likely an event is occur. We have a number line. With 0, if you have a 0 probability, that just means that whatever event you're trying to find the probability of, it's impossible. It can never happen. If the possibility of an event happening is 0, that means it'll never happen. It's impossible. If the probability of an event happening is 1, that means that it's certain to happen or it's absolutely going to happen, right? So for example, what is the probability that the sun will rise in the morning? Well, it rises every day. So we're fairly certain. Notice how I said I use the word certain and not like absolutely certain. I'm not using anything more powerful. It's certain because as far as we know, it's going to happen. Right? That's what that means. It doesn't mean that it's going to happen every single time for all eternity. That's not what it means. Okay, it's just probability means that we're really, really sure that it's going to happen. Probability, however, is all the in-betweens, right? What is the probability of me getting heads when I flip a coin? It's going to be 0.5. It's going to be 50%, right? Is it possible for me to get heads? Yes. Is it possible for me to get tails? Yes. The chances of me getting either of them are 50%. Any number in between 0 and 1 is a probability. Those are decimals, and decimals can be turned into percents, and we're used to seeing probability in terms of percentage, right? So that's the background. You are going to be calculating the percentage of the probability of certain outcomes happening. Now, if you notice, I see P of A in there. That is the probability of event A happening, right? So the probability of event happening is the number of outcomes in the event over the number of outcomes in the sample space. That is denoted by, and if you notice, this is a symbol that we had in our chart. Well, not this one, this one. You guys remember this? NA, NB, NC, right? The numbers inside of a subset, that's that symbol, and we're going to use them, right? Pretty much the probability of event A happening is the chance of the event happening, whatever the event is, whether it's you flip a coin, you roll a dice, whatever. What is the chance of a specific event happening? Divided by the total chance possible. That's really what that bolded, typed out thing says. To the left is the way that it's said in math language, and in the right is kind of what it actually means. And n of a and n of s is just the notation, the variable we're going to use to represent this problem, because I don't feel like writing that entire sentence every time I need to find p of a. So that's why we use n of a, n of s. Okay, so the problem, background to the problem that you're going to do, right? You roll a numbered cube. So for all of these problems, we're going to be thinking about a cube, right? Event A is rolling a prime number, right? So we have a dice, and in the dice, there are 6 sides to the dice, right? I want you to think about that for all these problems, right? Just picture the dice. Event A is rolling a prime number. So if I roll a prime number and I end up getting this, is this a prime number? No, right? But what was the chance that I would roll a prime number, right? That is what you have to think of for event A. Event B is rolling an even number. Well, did I roll an even number? Yeah, I did. So what was the chance of that happening? I want you to find the probability of that, okay? So if you notice, you're gonna have these 4 things to look at. Find P of A, P of event A, union with event B, probability of event A intersecting with event B, probability of event A's complement, right? Now, if you notice, those are things from this chart. That's the notation. I want you to find the actual numbers. Okay, here's how you do the problems, right? All that was to do this. Okay, so if we're finding PA, we're rolling a prime number, right? A dice only has 6 sides, which means that the entire possibility of rolling, right? Every time I roll this dice, I'm gonna get a number between 1 and 6. That means that the total outcomes, that NS that I have here, is the total possibility. What are the total number of possibilities? Well, there's 6 possibilities. I either get numbers 1, right? 2, 3, 4, 5, and 6, right? I'm gonna get one of those numbers every single time. So there's a total of 6 possibilities, right? That's why 6 is a denominator. Well, in order for me to find out the probability of rolling a prime number, I need to know what a prime number is. Prime number is just a number that can only be divided by itself and 1. So within numbers 1 through 6, right, the prime numbers are going to be 2, 3, and 5, right? Because 1 is not a prime number. 4 can be divided by 2 as well as 1, and 6 can be divided by 2 as well as 3, right? So 1, 4, and 6 are not prime numbers. The only prime numbers are 2, 3, and 5. If you notice here, that means that there are 3 numbers in that set, and that means that the 3 goes on top. So what is the probability of rolling a prime number? 3 out of 6, right? Because if I get any of those 3 numbers, I roll the prime number. That's half. So what is the probability of me rolling a prime number? Half, or 0.5, right? At this point, I hope you realize that this is a lot more simple than it sounds, right? I'm giving you all the background because some of the problems might be harder, and part of this lesson is you need to know the vocabulary. So even though the examples are simple, you need to understand and be able to read what the problem is asking you. That is what I'm looking for. Okay, so to find P, the probability of event A union with event B. In other words, we're going to combine all the elements of set A and set B. In other words, all the even numbers, we're going to combine all the even numbers and all the prime numbers together, right? So the numbers inside of the combined elements over the numbers, the total numbers possible. Now, if you notice, the total number possible when I roll a dice is 6. So if you notice, 6 is my denominator. Now, if you look on the right here, I have U, A, B, and then I have all the sets. U is all the numbers possible, right? So this is this. Set A and set B, union just means I combine all of them, right? So if you notice here in set A is 2, 3, and 5. Set B, if you remember, is just even numbers. 2, 4, and 6 are even numbers, right? So if I were to combine the numbers inside of set A and B, I have 2, I have 3, I have 4, I have 5, and 6. 2 is repeated, so I'm not going to repeat that. There is exactly 1, 2, 3, 4, 5. What is the chances of me getting either numbers inside of set A, rolling a number inside of set A or set B together? Well, there's 5 numbers that I can roll. The only number that's not in set A or set B is number 1. 1 is not a prime number. 1 is not an even number. Therefore, I have a 5 out of 6 chance of rolling a number inside of a union between set A and set B. That's it. That's my answer. Okay, now for the last 2, right? We're almost done, I swear. Find the probability of event A, right, intersecting with event B, right? Now, intersection is what they have in common. Now, if you notice down here, we have set U. These are all the possibilities. When I roll a dice, right, the total possibilities are I can either roll a 1, a 2, a 3, a 4, a 5, or a 6, right? Set A is all the prime numbers, 2, 3, and 5. Set B, right, is all the even numbers, 2, 4, and 6. Now, if I want the intersection, I want to know what number both sets A and B have in common. The only number that they both have in common is circled is 2, which means that if I want to find the number of numbers that are intersected between A and B, there's only one number. So that's why there's a 1, right, on my numerator. And the total number of numbers, the total number of possibilities of when I roll a die is 6. So therefore, the intersection of probability, the probability of set A intersecting with set B is 1 out of 6. Because in order for me to get a number that was in both set A and set B, I have to roll 2. And there's only 1, that gives me a 1 out of 6 chance, all right? Okay, so hopefully that wasn't too confusing. Let's do the last one. The last one is the probability of set A's complement. What is the probability of me rolling a number that is set A's complement? Set A is what's not, the set A complement is what's not in set A. any number that's not in set A but is in the universal set is a number that I'm looking for. So if you look at the universal set, I have 1, 2, 3, 4, 5, 6 again, and I'm only dealing with set A this time. I'm gonna take out all the prime numbers. I don't want the prime numbers this time. So that's why I canceled them out. 2 is canceled out, 3 is canceled out, 5 is canceled out. That leaves what numbers are in the universal set that are not in set A? 1, 4, and 6. That's 3 numbers. So the numbers inside of set A complement is 3 divided by the number of total possibilities is 6. What is the possibility of me rolling a complement to set A? 3 out of 6 or 1/2. Okay. Okay, so that was a long one, guys. Sorry about that, but we are going to be doing probability and things like this for the rest of class. So this is your introduction to it. The problems that I want you guys to do, right, are going to be, give me a second, homework and practice problems 1 through 12, right? So let me write that here. I want you to do problems 1 through 12, and we will come back to this, right? If you have any questions, please go into my Zoom from 1:30 to 3 p.m. for all math questions. You can email me, or you can leave a comment in the Google Classroom, and I'll try my best to get to you. All right, guys, good luck, and let me know.